Okay. So let's say we have two functions, f and g, whose graphs are shown this way. So here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the graph of the function f is, it goes straight up like this. And then, actually, let's see, two steps. Goes way up there, 6. And it falls down, this is 2. It falls down to very falls down to, let's say, 6. So let's say this is a graph of f of x. The second graph is this is let's see, for okay, actually this will be, so at 4 this will be 3. And this is a horizontal line, so this point here is 1, 3. Okay, for these, by the way, I should name this as g. This function here is g of x. For this, let's define p of x equals to fx times gx, p for the product, q of x as fx over g of x, and h of x as f composed with g of x. Now let me ask a few questions. A, f of 4. B, f prime of 4. C, g of 4. D, g prime of 4. E, p prime of 4. F, q prime of 4. And then G, I want h prime of 0. So let's try to settle these questions. Okay, F4 is easy, right? What's f of 4? Yeah, so this is the graph of f of 4. So if you go to location 4, you see that the value, the altitude, is 3. So the value of f is 3. What's f prime of 4? What's the meaning of the derivative? It's the slope of the tangent line, but this is a straight line apparently. So if you draw the tangent line to a straight line, it's the line itself. So we're really looking at the slope of this portion of the graph. Okay. So you have to first identify the points 2, 6, and 6, 0, and you have to find the slope. How do you find the slope? You subtract the 2, subtract, you get 6 and negative 4. The difference of the y is called the change of y. Difference of the x is called change of x. What's the slope? Change of y over change of x. So dividing 6 by negative 4 will give you 3 over 2. That will be negative 3 over 2. What's g of 4?
1.
What's g prime of 4?
0.
0, because it's a horizontal line, right? Horizontal lines have 0 slope. Okay. Now, starting from E, that's when it gets interesting. Let's think about this. What is E asking you to do? You have to find the derivative of P of x, and you have to plug in 4 into the derivative. That's what it's asking you to do, right? This P prime of 4 means first differentiate and plug in 4. Now what is P of x anyways? F of x times g of x. So you have to differentiate this and plug in 4. How should you differentiate this? Yeah, it's a must, right? It's a product of two functions, so is product rule optional? No, it's a must. If you ignore the product rule, do you get any credit? No, 0, okay? You have to use the product rule, which says differentiate the first one, leave the second one, plus the first one times differentiate the second one, and then plug in x equal to 4. So let's write that down. So what are we doing? F prime of 4, g of 4, plus f of 4 times g prime of 4. Okay, now look at these values. We know them all. We did them from A through D, right? So we can just plug them in. This is negative 3 over 2, g of 4 is 1, f4 is 3, g prime of 4 is 0. So the answer is negative 3 over 2. So the answer to this one is negative 3 over 2. Q prime of 4. How about that? It's the same exact story, right? So if you did the derivative of this thing, you have to use the quotient rule. Let's think about what the quotient rule would say. The quotient rule is f prime of x times g of x minus f of x times g prime of x over g of x squared, right? The denominator squared. And then into here, I'm supposed to be plugging in 4, right? So you plug in 4. So I plug in 4 here. Oh, so this is again, if I plug in everything, you get negative 3 over 2. It's a little unfortunate. I would like it if all the answers were different. This is just a coincidence that everything was same. Usually it's different, okay? So you can check that these values will give you that. I just want to finish that part quickly. Oh, you're still copying? Okay. Sorry about this. Yeah.
So it's the top key right over there.
All right. Okay. So let me try writing over that side. So let's try h prime of 0. So what does that mean? That means you take the function h, differentiate, and then plug in x equal to 0. What is h of x? It's the composition of f and g. And this circle thing means simply that g of x is inside. You have to plug in g of x inside the function f. That's what it means. Function composition means you're just plugging one function into another function. And once you write like this, it's very clear which one is the nested function or the inside function and which one is the outside function, right? So this is a nested function, that's the this is an inside function, that's the outside function. What does the chain rule say? Okay.
It's the derivative of
Yeah.
outside as the inside.
Derivative of the outside times
The inside
g of x
times the derivative
times the derivative of the
inside.
inside. Okay. And then you plug in x equal to 0. So f prime of g of 0 is what we're looking for, times g prime of 0 is what we have to do. What's g of 0? So in that graph, we see that g of 0 is 2. And what's g prime of 0? Well, the 2 points are 0, 2 is this point. The other point is 2, 1. So if you subtract, you get 1 as a change of y and negative 2 as a change of x. So if you divide the two, we see that g prime of 0 is negative 1/2. So going back, we see that g of 0 is 2, and g prime of 0 is negative 1/2. Now we have to figure out what f prime of 2 is. Okay, so we have to go back and look for f prime of 2. Uh-oh. Well, what do we see at f prime of 2? It's a cusp, right? So what's the derivative of f at 2? dne. Right. So in that case, the answer to this, which could be possible, right? Not all derivatives should exist. So even after this long hard work, the answer is that the h of x does not have a derivative at 0. Yes, you have a question?
For B, f prime of 4, what? I thought anything prime with a constant was 0.
Oh, yeah, okay. So the question is, f of 4 is 3, so isn't f prime of 4 0? Okay? And that's why I was insisting that you use the following form. When I was saying p prime of 4, I said this is really p of x prime and then x equal to 4, right? So same thing goes on here. When you have f prime of 4, you should really think of this as you first differentiate the function and then you plug in x equal to 4. That's what it means. That's different from see, on the other hand, if you have f of 4 evaluated first, and then you differentiate, what is this value? It's 0. Because f of 4 is 3, and 3 differentiates to 0. Okay? So those are the differences. Okay? And that's why it's important to rewrite these into this form when you continue to work with it.